Hello and welcome to lesson 5.3, other quadrilaterals. Today we're going to look at quadrilaterals that are not parallelograms. And the first one we're going to look at is a trapezoid. The trapezoid is a quadrilateral with exactly one pair of parallel sides. And our trapezoid has two bases, and our bases are always parallel. So here's one of my bases, and this is the other. And each of those bases has a pair of base angles. So Q and R are base angles, and P and S are a pair of base angles. And we have two legs. The legs are the sides that are not bases. So this guy here is a leg, and this guy here is a leg. There are two pairs of supplementary angles. I'm running out of space, no. Supplementary angles in any trapezoid. And those supplementary angles are always the two angles that lie along each leg. So P would be supplementary to Q, and R would be supplementary to S. Those are my supplementary angles. Any trapezoid, we can draw in a segment called the midsegment, just like in a triangle. Midsegment. And the midsegment of a trapezoid is drawn between the two midpoints of the legs. The midsegment is parallel to both bases, and its length is half the sum of the lengths of the bases. It is therefore the average of the bases. So let's take a look at some examples. So right here, if I tell you that QR is 6 and PS is 20, I want to find, that should say TU, by the way. Well, QR and PS are both the lengths of my bases, and TU is the midsegment. So I know that TU has to equal QR plus PS divided by 2, which is 6 plus 20 divided by 2, or 26 over 2, or TU is in fact 13. We can also work backwards. What if I give you the length of the midsegment and ask you to, and one of the bases, and ask you to find the other base? Well, we simply plug into the formula. 19 equals 9 plus PS over 2. I'm going to multiply by 2 on both sides. So I get 38 equals 9 plus PS. Subtract the 9 over, and I get that 29 is the length of PS. And we can also do this a little bit more algebraically. I can give you different algebraic values for your segments. So TU is 3x minus 6, and that has to equal 2x minus 1 plus 25 divided by 2. I'm going to start off by multiplying both sides by 2 to get rid of my fraction. And I get 6x minus 12 equals, this becomes 2x minus 1 plus 25 becomes plus 24. I'm going to get all of my x's on the same side and all of my numbers on the other side. So I end up with 4x equals 36, so x is 9. We have a special kind of trapezoid called an isosceles trapezoid. And an isosceles trapezoid is a trapezoid where both of the legs are congruent lengths. So the trapezoid you see in your head when you think about trapezoids, that's the isosceles trapezoid. And if a quadrilateral is an isosceles triangle, then each pair of base angles are congruent. So Q would be congruent to R, and P would be congruent to angle S. Also, if a quadrilateral is an isosceles triangle, then the diagonals are congruent. So PR would be congruent to SQ. So let's take a look at these. Here's some examples. All right, so in this one, they give me the measure of two angles that lie along the same leg. And two angles on the same leg will always be supplementary. So 10x plus 60 plus 8x minus 40 must equal 180 degrees. So I combine my like terms. I get 18x plus 20 equals 180. So 18x equals 160. X equals 160 over 18, which reduces down to 7. Ooh, that should be, pause. Which reduces to 80 over 9. All right, so this next diagram down here, they give me BD, which is one of my diagonals, and then they give me CA, which is the other diagonal. So to solve this one, all we would do is set the diagonals equal to each other. 9x minus 37 would equal 3x plus 5. I want you guys to finish this example on your own. Our last big umbrella term in quadrilaterals are called trapeziums. And trapeziums are quadrilaterals with no pairs of parallel sides. This is a word only used in the US. In the UK, trapeziums and trapezoids are the same thing. But hey, the UK is kind of crazy, so we're going to ignore that and say that a trapezium has no pair of parallel sides. There is one special kind of trapezium, and it is called a kite. And yes, it does look like the thing we used to fly as children. A kite is a quadrilateral with exactly two pairs of consecutive congruent sides. So if I have consecutive congruent sides, that means that WZ and WX would be congruent, and XY and ZY would be congruent. Opposite sides cannot be congruent, otherwise we'd wind up with all four of our sides congruent and get 4 consecutive pairs, which would make this guy a rhombus. And a kite is also a trapezium. It's a subset of trapeziums. If a quadrilateral is a kite, then its diagonals are perpendicular, okay? One and only one diagonal will be bisected by the other diagonal. So WY bisects XZ such that this piece will equal to this piece. This would make WY the perpendicular bisector of XZ. And one and only one pair of angles will be congruent. In this diagram, angle WXY will be congruent to angle WZY. So this angle is congruent to this angle in my diagram. So there's a lot going on in a kite. Kites are pretty cool. So right here, I want to find the values of X and Y, things I can see immediately. If this side here is 3y, then this side is 3y. And if this side is 6y minus 2, then this side is 6y minus 2. They tell me my perimeter is 86, so that means that all of my sides, 3y plus 3y plus 6y minus 2 plus 6y minus 2 must equal 86. So I end up with 18y minus 4 equals 86, or 18y equals 90. So y must be 5. Yeah, y is 5. And looking at this, 2x plus 3 must equal 5x minus 12, because that's the side, that's the diagonal that's bisected by the other diagonal. So I need to get getting that 3x equals 15, so x is 5. Yay. All right, and last but not least, we have giant table to summarize everything we have learned so far. I am a big proponent of organizing your knowledge when you've got lots of tiny details, and in quadrilaterals, that is certainly the case. So let's take a look at each of these shapes and summarize all the things we've learned in the last 2 lessons. So parallelograms have 2 pair of parallel sides, and my opposite sides are congruent. When I look at the angles, my opposite angles are congruent. And when I look at the diagonals, my diagonals in a parallelogram bisect each other. Now, a rhombus is a parallelogram, so I'm going to write all parallelogram, but it's got some extra things added on. All my sides are congruent, which means we can say that it is equilateral. And my angles in a rhombus are bisected by my diagonals. And my diagonals in a rhombus are perpendicular. Okay. Rectangles also have all the properties of parallelograms. And then they have some extra things. Their sides are perpendicular, which means that all angles equal 90 degrees. So we say that this is equiangular. And in a rectangle, my diagonals are congruent. Ooh, my symbols are not working here. My diagonals are congruent. Now, the square is my regular quadrilateral. It has all properties of parallelograms rhombi, and rectangles. Ooh, come on. Now, just because I like to list it, it is equilateral, it is equiangular, and the diagonals are both congruent and perpendicular. So, yay. So now we've done all the types of parallelograms. Now let's look at trapezoids. Well, my trapezoid is defined as having one pair of parallel sides, exactly one pair of parallel sides. With the angles, we have two pairs of consecutive supplementary angles. And there is actually nothing special about the diagonals of a trapezoid, just a basic trapezoid, nothing cool happening there. An isosceles trapezoid has all of the same concepts as a trapezoid, but it has some extra things added on. For example, the legs are congruent, and my base angles are congruent, and my diagonals are congruent. Yay. So then we go into trapeziums. Trapeziums have no parallel sides. And because trapeziums are typically pretty funky looking, we have nothing special to say about the angles and nothing special to say about the diagonals. Kites, on the other hand, are awesome. So they have all the same things as trapeziums, because they are a type of trapezium, plus some cool things. We have 2 pairs of consecutive congruent sides. Angles, we have 1 pair of congruent opposite angles. And then my non-congruent angles are bisected by the diagonals. Come on. Why isn't that writing? Diagonals. Okay. My diagonals are perpendicular to each other. And then one diagonal is the perpendicular bisector of the other diagonal. So that therefore summarizes for you everything you need to know about quadrilaterals. So thank you very much. Have a great day.